Good afternoon and welcome to today's Clean Water State Revolving Fund Emerging Contaminants webinar. My name is Sydney Merrill and I'm on the webinar technical support team at ERG, which is the contractor supporting this effort. Before we get started, let's review a few housekeeping items. Audio is available for this presentation through your computer's mic and speakers or by telephone. Your call-in number can be found by clicking the upward arrow by the mute/unmute button in the Zoom control panel across the bottom of your screen. After you click the upward arrow, choose Switch to Phone Audio and then follow the instructions provided. All attendees have been muted to minimize background noise. This webinar will be recorded and posted to EPA's website at a later date. We'll have several panelists today presenting and we'll introduce them in just a moment. If you are experiencing any technical difficulties, please contact us via the Q&A box or email me at sydney.merrill@erg.com and we will try to troubleshoot the issue. If you have a question during the presentation, please type it into the Q&A box located in your control panel. We'll hold questions until the end for a combined Q&A session. So that's everything for housekeeping. So I'll turn it over now to Kelly Tucker at EPA.
Hello, everyone. I'm Kelly Tucker with the Clean Water State Revolving Fund program at EPA headquarters. I'm going to do a quick introduction of our speakers this morning. Today, you will hear from myself. I am, again, with the Clean Water State Revolving Fund program. We'll also hear from Sminny DePaul and Heather Strathern with the Sustainable Communities and Infrastructure branch at EPA headquarters. We also have a number of state SRF program representatives who will be talking about the emerging contaminants projects that they are planning to fund in their states. Next slide. So today we will start out giving an overview of the Clean Water State Revolving Fund program, as well as an overview of the Clean Water SRF Emerging Contaminants Supplemental funding. We'll also talk about various emerging contaminant project ideas and examples. And hear from the state representatives on case studies of projects they're planning to fund in their state. And we will end with plenty of time for questions and answers. Next slide. So we just wanted to have a quick polling question before we get started. And we are wondering, what is your professional affiliation? Okay, thank you for your responses. It looks like we have a number of state staff, as well as a large number of utility staff on the call today. Next slide. So I am going to jump right in to give an overview of the Clean Water State Revolving Fund program. So the Clean Water SRF is a low-cost source of financing for a wide range of water quality and public health projects. The program operates in all 50 states and Puerto Rico, so there are 51 different Clean Water SRF programs. The programs operate like banks. EPA provides seed money in the form of a capitalization grant to each SRF each year, and the SRF uses those funds to make loans to eligible borrowers for eligible projects. The borrowers repay those loans, and those recycled funds are then used to provide loans for additional projects. The SRFs are primarily loan programs, but the programs do have the ability to provide some financial assistance in the form of grants and forgivable loans. Next slide. The SRFs are state-managed programs that have a great deal of flexibility to target resources to their specific priorities and needs. The states are responsible for setting loan terms, including interest rates that can go from 0% to market rate and repayment periods up to 30 years. The low interest rates that are offered by the Clean Water SRF program provide substantial savings to communities and other eligible borrowers. Another great savings offered by the Clean Water SRFs is called additional subsidization, and that is provided in the form of forgivable loans or grants. Next slide. So as I said, these are state-managed programs, and it's the states that are responsible for developing priority setting systems to score and rank projects and select the projects that receive funding. The states are also responsible for making decisions about how additional subsidy is distributed within the state. So for that reason, it's very important to get to know the SRF program within your state and understand their application process and eligibility requirements, and also to participate in their public review process to provide feedback on the projects that have been selected to receive funding each year. Next slide. So who's eligible to use the Clean Water SRF? The Clean Water Act sets specific criteria for who is eligible to receive Clean Water SRF financial assistance. Eligible assistance recipients are based upon the type of project. So municipalities, intermunicipal, interstate, or state agencies are eligible for the construction of publicly owned wastewater treatment facilities. And then for other project types, such as stormwater management or agricultural best management practices, nonprofit entities, watershed groups, homeowners associations, and others are also eligible. Next slide. The Clean Water SRF has 12 statutory project eligibilities. These eligibilities allow the Clean Water SRF to fund a wide range of wastewater infrastructure and water quality projects. Next slide. So under those 12 statutory eligibilities, the Clean Water SRF can fund centralized wastewater treatment, stormwater management, decentralized wastewater treatment, and water and energy efficiency, as well as non-point source projects such as agricultural best management practices, landfill capping and leachate control systems, and the water quality portion of the cleanup of contaminated sites or resource extraction sites. I do want to mention that the Clean Water SRF can fund capital projects as well as planning and design where there's a reasonable expectation that it will result in a capital project. But the SRF cannot fund operation and maintenance expenses. We've provided a link on this slide to our overview of Clean Water SRF eligibilities, which provides more information on the types of projects that are eligible for Clean Water SRF assistance. Next slide. The Bipartisan Infrastructure Law, or bill, also referred to as the Infrastructure Investment and Jobs Act, is the single largest federal investment in water infrastructure. $50 billion was appropriated to EPA through the bill, and the majority of EPA bill funding, $43 billion, will be distributed through the state revolving fund programs. This includes supplemental funding to both the Clean Water SRF and Drinking Water SRF programs for water, wastewater, and stormwater projects, as well as funding for Clean Water SRF and Drinking Water SRF eligible projects that address emerging contaminants, and funding for lead service line replacement. Next slide. EPA has several goals for the implementation of the Bipartisan Infrastructure Law. These include targeting resources to disadvantaged and underserved communities. A key priority of the bill is to ensure that disadvantaged communities benefit equitably from this historic investment in water infrastructure. EPA is working to engage with these communities and to identify needs and help them access funding through our technical assistance efforts. Our second goal is to make rapid progress on lead service line replacement and lead-free water for all. Through the bill, Congress appropriated $15 billion in funding dedicated to lead service line identification and replacement. Tackling forever chemicals. The bill provides $5 billion through the state revolving funds to address PFAS and other emerging contaminants. We also want to support resilience and One Water innovation. With the broad range of eligible projects that can be funded with the bill, EPA encourages states to utilize this significant increase in funding for infrastructure projects that make water systems more resilient to natural disasters, climate change, or threats such as bioterrorism and cyber attacks. And then finally, bill investments will create jobs in construction, operations and maintenance, and other water careers. Next slide. So this afternoon, we're focused on the $1 billion of bill funding appropriated for Clean Water SRF projects that address emerging contaminants. And these funds are distributed to the states based on the current Clean Water SRF allotment formula in the Clean Water Act. And all of these funds must be provided as additional subsidy in the form of grants and forgivable loans. Next slide. So what is eligible for the Clean Water SRF Emerging Contaminants Funds? For a project to be eligible, it first must be eligible under Section 603 of the Clean Water Act. So to be eligible for emerging contaminants funds, the project must meet one of the 12 statutory eligibility criteria described earlier in the presentation. And the primary purpose of the project must be to address emerging contaminants. So to provide some clarification on this, we recognize that many projects will serve multiple purposes and address multiple contaminants. So that's okay, as long as one of the purposes of the project is to address an emerging contaminant that is known to be present. Next slide. As I said earlier, the Clean Water SRF can only fund capital projects, and that includes planning and design for capital projects, as well as broader water quality planning, such as the development of a stormwater management plan or a TMDL implementation plan, where the planning involves the identification of eligible capital projects. The Clean Water SRF cannot fund operation and maintenance activities, and in general cannot fund monitoring. There are some exceptions, and Smitty is going to talk about that in just a minute. Actually, I think she's going to talk about it right now. So I'm going to turn it over to Smitty.
Thank you, Kelly. Good afternoon, everyone. Thank you for joining this webinar. I'm going to quickly go through the definition of the emerging contaminant that Clean Water SRF has developed, and go through some eligible projects that may be covered through this fund. So in order to provide a definition that captured most of the emerging contaminant categories, we researched internally and externally using existing definitions and peer-reviewed information. With that information, we used to finalize the definition for Clean Water State Revolving Fund Emerging Contaminant to include substance or microorganism, including manufactured or naturally occurring physical, chemical, biological, radiological, or nuclear material, which is known or anticipated in the environment, which may pose newly identified or re-emerging risks to human health, aquatic life, or the environment. So this can include many different types of natural or manufactured substance, such as the personal care products, your pharmaceuticals, industrial chemicals, pesticides. Next slide, please. So some of the examples for are PFAS, of course, antimicrobial resistant bacteria, and 6-PD quinone from tires. As we explored further into the definition, we realized that we needed to place some boundaries around the definition as it related to the types of contaminants. So we looked to the Clean Water Act for guidance and came up with contaminants with water quality criteria, recommendation published by EPA under Clean Water Act Section 304A, except for PFAS, are not considered emerging contaminants. I do want to emphasize that this definition is only for the purpose of Clean Water SRF financing. We have a separate definition for drinking water emerging contaminant, which you can find on EPA's March 2022 memo in Appendix B, and we have also provided a link to that document. Next slide, please. So from our conversation with states and utilities, we understand that it may be difficult to identify emerging contaminant projects right away and need additional monitoring data to identify presence and quantity of emerging contaminants, whether it's stormwater or wastewater. So, and once monitoring data is in, the resulting option could be varied. So some may be SRF eligible capital projects, or an option that is not eligible for SRF funds. Next slide, please. So the next few slides are meant to provide some practical project ideas and examples in identifying eligible projects for funding. We will also discuss means for addressing current limitation related to monitoring and planning. So here are some high-level consideration when looking for projects that are Clean Water SRF Emerging Contaminant Fund. So monitoring as part of projects for planning and design. For example, your wastewater characterization for POTWs may be eligible. Consider projects that are already in pipeline that address emerging contaminants and look beyond POTW construction and PFAS to stormwater, landfills, contaminant sites, which can also be a significant source of emerging contaminants. Next slide, please. So provided that there is a reasonable expectation that the planning will result in a capital project, planning and design and water quality planning, such as your stormwater management plan that results in BMPs, may be eligible. So funding can be used for pre-construction activities to help prepare planning, preliminary engineering, and alternative analysis documents. Next slide, please. So again, monitoring is eligible for specific purpose of project development. These include, again, the planning, design, and construction that I mentioned earlier. There are built-in flexibilities when it comes to monitoring for the specific purpose of project development over a reasonable time frame. This is because we understand the time frame may be different depending on the contaminant you're looking at, the location, or may be affected by seasonal variation. After the monitoring is completed, the outcomes may be other than capital project that address the emerging contaminants. We won't know until that monitoring is completed at that point. Another thing to note is that the funding may also be used for certain project types to assess effectiveness after construction. So an example of that would be for non-point source projects and green infrastructure projects. The startup period to assess effectiveness of the technology may be eligible, and states can determine what is that reasonable startup period. Next slide, please. So within the monitoring realm, here are some eligible activities. So any equipment purchased for the purpose of monitoring, so for example, auto samplers or equipment for lab analysis, may be eligible for through this fund. And in order to identify and select a treatment technology and project alternative, there needs to be monitoring performed to characterize stormwater or wastewater. And this will help, inform an engineering report. And this type of monitoring may be eligible through Clean Water SRF, Emerging Contaminant Fund. The other eligible monitoring may include monitoring of wastewater effluent, and sludge to determine the fate of emerging contaminants and to inform the identification and selection of your appropriate treatment technology. So we have a presenter from Iowa Department of Natural Resources, Satya Chenupati, who will present the Cedar Rapids case study later and discuss some monitoring activities being undertaken as part of the project. Next slide, please. Thank you. So some of the other project ideas that may be eligible through this fund, starting with just wastewater treatment facilities, obviously projects that remove emerging contaminants from biosolids or wastewater discharge. And if utilities are interested, consider demonstration projects, right, to evaluate technologies before a full-scale implementation. I know right now many utilities are looking at PFAS, and there are many new and upcoming PFAS removal and destruction technologies. Utilities are able to use this fund to demonstrate, to do a demonstration project of these technologies to assess effectiveness. Later in our presentation, Heather Strathern will be covering some upcoming research and new information on technologies to treat emerging contaminants that could lead to a demonstration project. Another potential eligible project is a project that can reduce energy consumption needs at the POTW. So for example, treatment of emerging contaminant before it reaches the POTW. Also consider using, thinking about advanced treatment technologies to remove PFAS and other emerging contaminants to facilitate water reuse. And we have another example by Lindsay Jones of Arizona Water Infrastructure Finance Authority, who will be presenting a case study in Tucson, Arizona that highlights the use of EC funds to facilitate reuse and remove PFAS. Next slide, thank you. Moving away from POTWs, looking at landfill projects may be eligible, especially if it is addressing emerging contaminant runoffs. So for example, capping project that address runoff from the landfill cells and leachate collection and treatment that will reduce PFAS runoff or load to the POTW. The emerging contaminant funds are also available for construction for newly publicly owned landfills, whether it's local or regional, or a modification or expansion of existing ones. So for example, adding a dedicated cell for PFAS contaminant waste. We also have an example on this. Beth Malcolm with New Hampshire Department of Environmental Services will be presenting a landfill case study that will be using the EC, Emerging Contaminant Funds. So we have covered some potential eligible projects in POTWs and landfills, but there is more this fund may be used for, such as brownfields, Superfund sites, and sites of current or former above ground or underground storage tanks. The actual projects may include addressing PFAS through capping, in situ treatment, or removal or contaminated material as part of the implementation of a state non-point source management plan. Another area to look into is surface water protection and restoration, where there may be projects that address emerging contaminants in water bodies. So for example, this funds may cover equipment for the physical or chemical removal of harmful algal blooms or HABs. And HABs removal could include strategically placing aeration blowers to remove and control algal blooms, or flocculant-based methods to facilitate algal removal. Next slide, please. Another area that is eligible is non-point source project. These may be publicly or privately owned, provided that they are capital projects that support the implementation of a current EPA-approved state non-point source management program, or 9-element watershed-based plan established under the Section 319 of the Clean Water Act. An example project will be presented by Lori Johnson of Oklahoma Water Resources Board, where she'll be talking about the Lake Thunderbird project. And under the regulated stormwater discharges, where emerging contaminants have been identified in stormwater, based on the previous monitoring efforts, look for projects that can trap or treat stormwater contaminants prior to reaching water bodies, or some kind of containment systems, whether it's covering contaminant storage areas. So this brings us to the next portion of our presentation, where Heather Stratton will cover the latest research on treatment technologies. Thank you. Heather?
Thank you, Smitty, for sharing that great information on project ideas and examples of eligibility. Like Smitty said, building on these project ideas, we want to share with you all some research on treatment technologies that might be applicable to these projects, particularly demonstration projects. And we're hoping to equip you all with the information and resources necessary to have projects that are successful in addressing these emerging contaminants. Before I get started, I do want to note that this is preliminary information, and we're focusing today specifically on per and polyfluoroalkyl substances known as PFAS, microplastics, as well as pharmaceutical and personal care products known as PPCPs. We recognize that more information is needed in these areas, and this is in no way exhaustive, and we'll continue to make additional information available. We also recognize that there's a lot of work being done in this area, so please do reach out to us if you have additional research that you'd like to share. And additionally, there's a great opportunity for pilots that are funded through CWSRF Emerging Contaminants to share information back to EPA regarding their treatment effectiveness, and we'd highly encourage folks to stay connected with us. So looking at this slide includes a few key links for you all to go back and revisit. The slides will be available to you all, so make sure to come back and take a look. The first link goes to reference documents used in this presentation, and the second link is a full clearinghouse of treatment technology information. And of course, it's important that I emphasize that EPA does not endorse any non-government websites, companies, technologies, internet applications, or any policies or information expressed by third parties. And before I move on into some of the pieces on the technologies, I want to note that the focus of this presentation really is on CWSRF emerging contaminants. So please hold any specific technology related questions and contact us after the webinar to continue the discussion. Okay, so starting, next slide, please. Oh, you've got it. Starting with per and polyfluoroalkyl substances, also known as PFAS, which are widely used, long-lasting chemicals whose components break down very slowly over time. EPA researchers are working on a lot of different aspects of PFAS research, whether that be developing methods for detection and quantification, or understanding toxicity and exposure and risk, as well as identifying effective treatment and remediation actions. So we've linked here to the latest methods for detecting and quantifying PFAS, and focusing specifically in on the treatment technology piece. Certain technologies have been found to remove PFAS from drinking water, including activated carbon, ion exchange resins, and high pressure membranes. And beyond these, EPA is actively working to identify additional cost-effective treatment technologies. And so with that, EPA has provided research briefs to quickly introduce potential technologies that might be appropriate for PFAS treatment. And the current briefs cover things like electrochemical oxidation, mechanochemical degradation, pyrolysis and gasification, as well as supercritical water oxidation. And so as water professionals, you all are really encouraged to think holistically about the full breadth of emerging contaminants that you might be treating for, and be thoughtful in your treatment technology choices to treat beyond PFAS. And so some additional ongoing EPA-funded research that we'd like to share with you all today on cost-effective treatment for PFAS includes some research on PFAS and land-applied biosolids and thermal treatment, as well as some extramural projects on separation and electrochemical treatment and electron beam breakdown of PFAS. So these represent just some of the many ongoing efforts to study PFAS treatment, and I would encourage you all to follow the link and read about the many other ongoing PFAS-related research projects. Next slide, please. Thank you. So EPA is just one of the many federal agencies researching PFAS, and I'd like to highlight another example of a federally funded research project. This project is funded by the National Alliance for Water Innovation, known as NAWI, which is a US Department of Energy program, and is investigating selective electrocatalytic destruction of PFAS using a reactive electrochemical membrane system. So this research is ongoing out of the University of Illinois, Chicago, and the team has many research partners, including national labs, water utilities, consultants, and other academic groups. And this particular technology focuses on PFAS destruction through reductive defluorination on the reactive electrochemical membrane, and you can learn more about it through following the link on this slide. So now, before moving on to microplastics, I will emphasize that the technology briefs and the selected ongoing projects are not exhaustive. We know that, and we'll continue to make information available to you all. We recognize there's a lot of work being done in this area, so please do reach out to us, like I said, if you have additional technology research that you would like to share. Next slide, please. Okay, so moving on to microplastics, which are synthetic solid particles or polymeric matrices smaller than 5 millimeters. Microplastics enter into the wastewater treatment plant from a variety of activities, including clothes washing, plastic container washing, stormwater overflows from plastic litter, and industrial waste. And treatment efficacy varies widely due to microplastics' variability in density, shape, charge, and chemical properties. And this is particularly relevant given the microbial growth and contaminant accumulation that can occur on the surface of microplastics. Additionally, a recent study found that the surface of microplastics can be an effective carrier of antimicrobial resistant genes. Next slide, please. Okay, so looking at the treatment for microplastics, conventional primary and secondary treatment has been shown to be effective in removing microplastics, and you can see on the slide some removal percentages for these treatments. However, it's important to be aware that microplastics are becoming embedded in the sludge. And so if a utility is recycling sludge as part of the activated sludge treatment process, microplastics are also being recycled through the plant. Similarly, it's important to consider microplastics during sludge, liquid waste stream, and biosolid disposal. Next slide, please. So this table presents a lot of information on select treatment technologies for removal of microplastics and is very preliminary. More research and information is needed. So starting at the top, technologies like reverse osmosis do require pre-treatment to be effective at removing microplastics. And even with pre-treatment, there are still concerns with microplastics damaging the membrane fibers. This differs from membrane bioreactors in the middle of this slide, which are less prone to fouling than other membrane processes due to the biodegradation of the plastics that's occurring in the biological treatment process prior to the membrane. And so with any treatment process, it's important to consider the waste stream with microplastics and what the ultimate disposal will be. Next slide, please. Okay, lastly, looking at pharmaceuticals and personal care products, also known as PPCPs, which include all drugs, both prescription and over-the-counter medications, as well as non-medicinal consumer chemicals, such as fragrances and lotions and soaps, and ultraviolet filters and sunscreens. So PPCPs have many pathways and sources to enter into a wastewater system, and testing is really difficult, partially due to the large number of compounds. EPA has developed a method that covers 74 of the compounds. And another important consideration and area of focused research in PPCPs is the development of antimicrobial resistance, either within the treatment system or being propagated in the environment from antibiotics that are in the effluent. Next slide, please. So looking at the treatment for PPCPs, some compounds have shown high removal rates with conventional treatment, but many compounds have not. As an example, some PPCPs like fragrances are more likely to absorb to solids during primary treatment, while others do not, but might degrade during secondary treatment. And only a few of the numerous compounds have been studied in depth. And so additional studies and information are needed to fully understand the fate of PPCPs in each treatment step and the concentrations remaining in the sludge, liquid waste streams, and biosolids. And so when considering treatment for PPCPs, it's important to properly monitor for the type of PPCP in the effluent and how each existing treatment process removes or degrades those PPCPs. Next slide, please. Okay, so similar to the last table, this table presents a lot of information. This is on selected treatment technologies for removal of PPCPs. Each treatment technology has different removal efficiencies for different compounds, and more studies are needed to fully understand the fate of PPCPs for each treatment technology and the process within the treatment train. And so moving down to the second row, constructed wetlands, more information is really needed on the soil and the plants and the concentrations of PPCPs in those and what the potential impacts to wildlife might be that are accessing the wetlands for habitat or food sources. And then moving down to the bottom, ultraviolet and ozonation as standalone treatments are not fully effective in degrading or removing all PPCPs. Some studies have shown that UV followed by ozonation could be effective, but still have some remaining PPCPs. So using UV or ozone in combination with hydrogen peroxide as an advanced oxidation process further promotes that degradation and removal. And so with any of these treatment processes, it's really important to consider the chemical composition of the free radicals that are created and the remaining PPCPs in the waste stream that's produced and what the ultimate disposal of that waste stream will be. So I'll conclude just by recognizing that this was a lot of information presented very quickly. So please do go through the linked references and the additional resources for more information. And I'll also emphasize that this is only preliminary information on treatment technologies that might be relevant to you all, particularly for demonstration projects. And the focus of this presentation is on CWSRF emerging contaminant eligibility. So if you have questions about specific technologies, we would love to speak with you offline about that. Next slide, please. And so with that, we'll continue with some of our polling questions. I'll start by saying that this information is really helpful to us in ensuring that we're supporting you all in the best way possible. So thank you for your efforts in answering the polling questions. So the second polling question should have just popped up for you all. And we're asking that for folks that are part of the utility staff be answering these questions so that we can really, cater our support to the utilities. And so the question reads, are you needing assistance with identifying projects for CWSRF emerging contaminants funding? Yes, we could use help. No, not sure yet. No, we don't need help. I'll just wait a moment while you all answer the questions. Okay, great. It looks like most folks, a slight majority of 55%, are not sure yet. So if you do need help, we are here as a resource and would love to support you all. So please do be reaching out. Next question, please. Okay, polling question 3, again, looking for utility staff to be answering these. Do you need funding to support monitoring activities to assess the presence of emerging contaminants? Yes, not sure yet, or no. And I'll wait a few minutes to let you all answer that question. Okay, great. Looks like a split between yes and not sure yet. Moving to the next question. What types of projects are you considering for Clean Water State Revolving Fund Emerging Contaminants funding? And please select all that apply, so you can choose multiple here. Publicly owned treatment works, stormwater, landfill, contaminated sites, surface water protection, or other. Okay, great. Looks like most folks for POTW, with some on surface water protection, stormwater, landfill contaminated sites, as well as others. So pretty good split between them all. And moving on to the last question, what emerging contaminants are you trying to address with your project? And we have per and polyfluoroalkyl substances, PFAS. We have antimicrobial resistant bacteria and pathogens. We have pharmaceuticals and personal care products, PPCPs, microplastics and nanomaterials, harmful algal blooms, also known as HABs, and other. Great, thank you. It looks like most folks looking at PFAS, but definitely some interest in addressing some of the other emerging contaminants as well. Okay, well, thank you all for taking the time to answer these polling questions. I will now pass it over to Kelly to introduce our amazing state speakers. Thank you.
Great, thank you, Heather. Now I am pleased to introduce our state speakers who will be discussing the emerging contaminants projects they are funding in their states or planning to fund in their states. First, we will hear from Lindsay Jones from Arizona about a water reuse project they are funding with emerging contaminants funds. Next, we will hear from Satya Chenapati from Iowa, who will discuss a project they are funding at the Cedar Rapids Water Pollution Control Facility. Then we will hear from Beth Malcolm about a landfill leachate project they are planning to fund in New Hampshire. And finally, we will hear from Lori Johnson, who will present on a non-point source stormwater project in Oklahoma. I will turn it over to Lindsay now.
All right, thank you, Kelly. So yes, I'm Lindsay Jones. I'm the Senior Program Administrator at WIFA, the Water Infrastructure Finance Authority of Arizona. Go ahead to the next slide. So I'll be discussing the Tucson project that we are in the process of funding right now. So first, just a little bit of background information about Tucson. For those who don't know, it's about an hour and a half south of Phoenix. And being a desert city and the ongoing drought, they are of course always looking for ways to add water to their water supply resources. So they do receive treated effluent, which they then store underground, or they send it out into their reclaimed water system. They use reclaimed water for irrigation at over 1,000 different sites throughout Tucson, and they also recharge it into their aquifer. Next slide. So besides being worried about water quantity issues, the city is also very concerned about water quality and specifically PFAS contamination in their groundwater. They currently do have an ongoing lawsuit against 3M and the other manufacturers of the firefighting foam, which they believe to be responsible for the high levels of PFAS. But of course, lawsuits take a long time, and Tucson's officials wanted to move forward with the remediation efforts as quickly as possible. So they approached WIFA in looking for financing for their project. So next slide. So this is their proposed project. They are looking to add on both UV treatment for the 1,4-dioxane they are finding in their water supply, and then the granulated activated carbon, or GAC, for PFAS treatment. So they plan to treat the water they pull out of the extraction wells before they send it out into their reclaimed water system. In total, they estimate that this project is going to cost about $74 million, which they are planning to use the SRF funding to finance. And because of the bipartisan infrastructure law, WIFA is able to commit to not only fund the whole project, but also to provide approximately $6 million in loan forgiveness to Tucson to make this project more affordable for the ratepayers. So we're very excited to have this really great use of our Clean Water SRF bill funds. And that is the overview of the project. So I believe next up we have Satya from the Iowa Clean Water SRF. Thank you.
Thank you, Lindsay, and good afternoon and welcome everybody to this webinar on emerging contaminants. My name is Satya Chandupati. I am the Clean Water SRF Engineering Program Manager for the Iowa DNR, responsible for Clean Water SRF projects. So today we'll be talking a little bit about our Cedar Rapids Water Pollution Control Facility project. Next slide, please. So Cedar Rapids is a town in eastern Iowa, about two hours from Des Moines. Des Moines is kind of the centrally located part of the state. It's considered eastern Iowa in Lynn County. So the population, Cedar Rapids facility serves population of over 180,000, including surrounding communities of Marion, Hiawatha, Robbins, Palo, and parts of unincorporated Lynn County as well. So the facility has a design average wet weather flow of 56 million gallons per day, and the organic load is the key here. 406,000 pounds per day. For those that are familiar with the per capita generation of BOD5 loading, so that's equivalent to about 2.4 million people. So just to put that in perspective, the total population of Iowa, according to the 20 census, recent census, is 3.2 million. So just to get a sense of the strength of the load receiving by Cedar Rapids wastewater facility. So primarily it treats residential, commercial, and industrial loads. And the waste from industrial contributors are, as you can see there, grain processing, food processing, cardboard recycling, metal finishing, and pharmaceuticals are the primary contributors to the city's wastewater facility. Next slide, please. So the primary treatment process of Cedar Rapids, it incorporates a very high strength industrial pretreatment process followed by a traditional activated sludge process. Cedar Rapids has two separate stage carbonaceous activated sludge and nitrogenous activated sludge processes. And the solids are treated by multiple hearth incinerators. Preceding that are gravity belt thickeners and belt filter presses. And then the effluent goes into the Cedar River post disinfection using chlorination and dechlorination methodologies. So the current city is currently involved as far as emerging contaminants are concerned. They're involved in an EPA research project. They volunteered to be included in there for studying the fate of PFAS, as Heather mentioned earlier, in solids after incineration, specifically the effectiveness of the multiple hearth incinerator that they have currently at the facility. However, the city recognized that alone is not going to be enough. They need to be identifying PFAS in the raw and treated liquid streams as well as the solid streams. So they need to have a better handle on what's coming into their facility and what's happening through their intermediate treatment process as well. So that's what the crux of the message is. Next slide, please. So here is a layout of the Cedar Rapids water pollution control facility. As you can see, main lift station pumps all the influent coming through. There is that high strength anaerobic pretreatment process to the top of the map there. And then the separate carbonaceous and the nitrogenous activated sludge process, the final clarifiers, and all of the solids handling to the lower left-hand corner, including the multiple hearth incinerator. They do have on-site ash lagoons, as you can see to the top right-hand corner as well. And all the discharge, as mentioned before, goes to the Cedar River. Next slide, please. And here is just a process flow schematic of the water pollution control facility. I'm not going to dwell too much. It's a little busy there. I just want to point out to that incinerator on the lower left-hand corner. That's where the incinerator process is for handling solids. Next slide, please. So back to the PFAS source and treatability study that is currently underway or going to be underway. So the study is divided into 4 separate and discrete tasks. The task 1 is the baseline sampling and analysis of PFAS components. The second is the evaluation of available alternative treatment technologies that are commercially viable for both solid and liquid streams based on the monitoring results. Third is the bench scale and our pilot scale testing of few of these options to find out make final recommendations that is task 4 in a final engineering report, sizing, layouts, and budgets. So next slide, please. So we talked about task 1 is the sampling and monitoring and analysis. So task 1, the first slide here is about the liquid stream. And as you can see, they're wanting to monitor the main lift station influent coming in, anaerobic pretreatment influent, primary clarifier influent effluent, secondary effluent, final effluent, solids dewatering decant lines, and the plant recycle lines. Next slide, please. And on the solid sampling, as you can see, the primary sludge, waste activated sludge, and then the low pressure oxidation treated waste activated sludge, the primary and secondary dewatered cakes, that's through the gravity belt thickener and the belt filter press, and the incinerator ash off of the multiple hearth incinerator. And just wanted to mention air quality and stack testing is not part of this project. This is purely on a water quality and clean water SRF eligible project only. Next slide, please. So we're talking about the Clean Water SRF project and funding eligibility. So currently the city has requested CWSRF emerging contaminant funds to support this project. Is it Clean Water SRF eligible? Yes, because there is a capital project at the POTW under the section 212 treatment works eligibility and under section 603C1 of the Clean Water Act. Are emerging contaminants present? Yes, because they are already detected in the EPA research study in the biosolids. Has the capital project been identified? Yes, because the monitoring and pilot projects most likely will result in a capital project to remove and or eliminate PFAS from the solids and or the liquid streams. Next slide, please. So where are we at in the entire process steps here? The city has submitted a CWSRF intended use plan application along with a report to us, to the Iowa DNR by December 1st. We are currently in the processing of the IUP applications, scoring, publish a project priority list, and it'll go through EPA review as well. And finally, it needs to be approved by our Environmental Protection Commission. And we are going to notify the city of Cedar Rapids about the project eligibility for the emerging contaminants funding. And then once the IUP is finalized, we need to apply for the emerging contaminant supplemental grant to EPA. And we need to receive that. As far as I know, it's running around 45 days is what we heard yesterday. So, and then once we receive the funds, DNR will notify the city of the funding availability, and Cedar Rapids at that point will commence the emerging contaminant study project. Next slide, please. And under task 1, just a little bit about the timeline. So once Cedar Rapids receives notification of the funding availability, they will have to go through the engineering procurement need to follow all of the federal cross-cutters and procure engineering services, then commence sampling and analysis and the results summary. That's going to take around 9 to 11 months. Task 2, the evaluation of treatment technologies, 3 to 4 months. Bench or pilot scale testing report, about 13.5 months, including mobilization, testing, and reports, and a final recommendation and report for about 2.5 months. That's the overall timeline of the entire project. Next slide, please. So finally, I just want to acknowledge Jim Fleming and Roy Hessman at the Cedar Rapids Utilities Department. And my contact is at the bottom of the slide. And thank you very much for your time. And next up is Beth Malcolm with the New Hampshire Department of Environmental Services. Take it away, Beth.
Thank you, Satya. Good afternoon, everybody. My name is Beth Malcolm with the New Hampshire Clean Water State Revolving Fund. And I'm happy to be here today to share New Hampshire's preliminary efforts to utilize the emerging contaminants funding under the bill funding and to learn about the opportunity from other states and EPA. 2022 was the first year of emerging contaminants appropriations, and the funds from these new capitalization grants are increasing in the coming 4 years. This works well for New Hampshire, as we find new initiatives take some time to gain traction in our program. Once the communities we serve are familiarized with the funding opportunities, we see interest and project proposals really take off. We're learning where the need is and what kinds of projects will serve New Hampshire communities. Next slide, please. Today, I'll provide an overview of our 2022 Emerging Contaminants program and highlight one of our projects. Our first request for emerging contaminants proposals was included in our regular project solicitation in April through May of 2022. And we received just one pre-application. As for future plans, we are expanding outreach to promote the funding for eligible activities. Next slide, please. When we learned these funds were going to be available, we were developing our Clean Water SRF pre-application and ranking criteria for our 2022 project priority list. The focus of our initial year was to propose to use the funds for PFAS in 2 areas. That would include source identification and elimination or reduction for 603C eligible activities, and opportunities to address landfill leachate discharge to municipal wastewater treatment facilities. The source identification work would help develop capital projects, and the funding presents an opportunity to assist our communities with handling PFAS and landfill leachate. While we did not perform a separate solicitation for EC projects, we adapted our pre-application to include a section for project proposals. Our pre-application is an electronic end form, which offers pick lists to applicants to describe their projects, as well as prompts them to submit relevant information we need to apply our ranking criteria. We also provide our ranking criteria with our pre-application to help make folks aware of the types of projects and project attributes the funding supports. The North Conway Water Precinct project proposal I'm going to describe today resulted from direct communication with our communities about funding opportunities administered by New Hampshire DES. Many communities, such as North Conway Water Precinct, are quite proactive and in contact with us regularly to inquire about ways to fine-tune and prioritize their infrastructure priorities. In return, we are frequently reaching out and making ourselves available through specific funding initiatives, as well as regular support services we provide for clean water. We have staff dedicated to the Clean Water SRF, project accounting and compliance, sustainability, design review, construction management, NPDES permits and compliance, residuals management, and operations. And our sustainability work includes asset management, planning, energy audit, measure, implementation, and resiliency and adaptation. Next slide, please. Especially with new initiatives in New Hampshire, we find it helpful to cast a wide net to assess need and direct the funding. So for our first round of emerging contaminants, we allowed communities to propose their projects without prescribing limits on the project scope. For source identification and elimination or reduction, the 2022 Clean Water SRF pre-application collected basic information about the residential, commercial, and industrial user base, the project description and goals. As we move forward with increased outreach and further discussions with the communities served, we will better define the need and expect to see an increase in project proposals. For the treatment of landfill leachate, along with the project description and goals, the pre-application was designed to collect information about landfills such as their active and or closed status, the volume of the landfill leachate, any existing pre-treatment that may be in place, and sewering and disposal. Next slide, please. So for the project overview, the current state is that the town of Conway landfill accepts the North Conway Water Precinct wastewater treatment facility sludge. In exchange, North Conway Water Precinct accepts town landfill leachate. An estimated $1 million in combined sludge leachate disposal costs is avoided per year through this partnership. Next slide, please. The complication is that North Conway Water Precinct's treatment facility is a groundwater discharge facility subject to AGQS standards for emerging contaminants such as PFAS. At least one of the monitoring wells currently exceeds the regulatory limits. And preliminary testing indicates the majority of PFAS loading is at the wastewater treatment facility is from the town landfill leachate. Next slide, please. So the goal of this project is to investigate the feasibility of PFAS treatment options for the landfill leachate stream. They wish to pilot test and select a recommended alternative and then prepare the project for full design, voter approval, and construction. Next slide, please. So we are currently developing our EC program goals and reviewing the guidance available. We hope some potential recipients were able to join today's webinar, and we are reaching out to wastewater treatment facilities receiving landfill leachate discharge. I'd like to point out that New Hampshire plans to offer Clean Water SRF grants for EC projects. Municipalities will not need the authority to borrow for loans under this program. The typical town meeting vote of the governing body will not be necessary, and however, communities will need the authority to accept and expend grant funds. So coming up in the spring of 2023, we will again request project proposals and make every effort to assist our communities in making good use of the EC funding. And next slide, please. We are very excited to be working with the North Conway Water Precinct on this project. This organization is proactive and thorough in their approach to evaluating and addressing the challenges of their infrastructure needs. We are confident the project will lend a better understanding of the situation and inform future efforts for New Hampshire communities. Thank you so much for your time today. And next up, we have Lori Johnson from Oklahoma. Lori.
Thank you, Beth. I'm Lori Johnson. I'm with the Oklahoma Clean Water State Revolving Fund program, and I wanted to talk today about a project that we're planning to implement in Oklahoma. It has not come to fruition yet, but doing some monitoring on a local watershed here for emerging contaminants. So first, I wanted to talk about the fact about funding. If you have a project that you're working to develop, I would advise to reach out to your SRF programs early. In Oklahoma, our first year allotment was only $755,000, which to me sounds like a lot of money, but in the world of infrastructure is really not that much money. So we wanted to be specific in how we use these funds so that we could develop some projects. And so for us, some planning and assessment uses of these funds was kind of the best fit for us. Also want to note in Oklahoma, our utilities are not yet testing for most emerging contaminants in their effluent. So trying to develop projects without some data already existing was challenging. So we meet with our other funding agencies regularly and trying to, once we heard the availability of these funds, really trying to focus our marketing and outreach efforts to where these issues already existed. And we heard of a lake that had already detected PFAS in the watershed. And so we reached out to that entity to help try to collaborate on this project and see if there was something there to utilize these funds. Next slide, please. Thank you. So Lake Thunderbird is located just south of Oklahoma City, right in central Oklahoma. This lake is utilized by 3 utilities for their water supply, but it is managed by Central Oklahoma Master Conservancy District. They are in charge of water resource development and control. This dam was a Bureau of Reclamation project. And the district is managed by a 7-member board with 3 representatives from the city of Norman and Midwest City each, and 1 representative from Del City, which is based on their allocation percentages is how they do their representation. This water body, Lake Thunderbird, does not have any discharges into the lake or into any of the tributaries that feed the lake. So the detection of PFAS in there was not coming from any wastewater effluent. It was coming from some sort of stormwater runoff or non-point source in the watershed. There have been previous studies done on this reservoir in an effort to inform some indirect potable reuse potential projects, which I'll go into a little bit later. And so that is one of the reasons that this is eligible for the monitoring funds under the CWSRF, is that there have been previously identified emerging contaminants within this water body. So the entity that was interested in doing an indirect potable reuse, they were proposing to send their wastewater to the reservoir to augment their water supply. So obviously there was a lot of public controversy from stakeholders, with one of their biggest concerns being contaminants of emerging concern entering into the lake from that wastewater effluent. That utility has done some pilot studies to test their wastewater effluent, and they are looking into upgrading their treatment processes to a tertiary filtration treatment to address any of the emerging contaminants. So just locationally, this is a map of the watershed, and just interestingly enough, the Tinker Air Force Base is located just outside of the watershed. So it's kind of unknown at this time if there's any contamination coming from that Air Force Base into the watershed or not. There has not been any studies that I'm aware of that link any of the contaminations to that Air Force Base, but that is just something kind of interest to note within this watershed. So as I mentioned earlier, thank you. I'm sorry, I'm not very good at telling you to advance the slides. Yes, you're on the right slide. So as I mentioned earlier, there was a study completed in 2017 for emerging contaminants on Lake Thunderbird. This was completed by the Oklahoma Geological Survey at the University of Oklahoma. And the purpose of this research was to provide the data to gain consumer confidence in support of, or not support of, doing this indirect potable reuse project. There were 110 emerging contaminants analyzed and 40 were detected. Most of the contaminants detected were pesticides, industrial compounds, hormones, personal care products. But something of interest in the report, the pesticides and the artificial sweeteners were detected in all 4 seasons. Next slide. And so the report actually made some recommendations for next steps, which actually was further studying to examine the seasonal differences in the detections and concentrations of the emerging contaminants, and to conduct a GIS-based study of potential sources within the watershed. So the proposal that we have for monitoring of the contaminants at Lake Thunderbird does not include a GIS-based study, but it does propose to study the scope and the location of where those contaminants are coming from. There has already been discussions of a treatment wetland within the watershed to help address some of these contaminants. And so this study will further inform the scope and location of that treatment wetland. So we have not funded this yet. It is in queue to be funded. They're working on doing a request for proposals to find a organization to help with some of this data and research, and we're hoping to fund it this spring. So with that is all I have, and I will turn it back over to EPA to close us out for question and answers.
Great. Thank you, Lori. Thank you to all our presenters today. I'm Janet Cherry with ERG, and I'll be moderating the Q&A. Thank you to everybody who submitted questions. I don't think we'll have time to go over all the questions, but we will reach out to some of you that have posed some specific questions on eligibility to help better understand your question and get the answers that you need. But again, great questions. We appreciate these. So let's get started. Lindsay, I'm going to start with you. A couple questions came in during your presentation. The first question was, what is the capacity of the Tucson Reclamation Facility in MGD? Do you happen to know that
So
that-
the
Mhm.
design capacity they are planning for is 38 million gallons per day. It's
Great.
not built yet, so.
Right,
Yeah.
right. Okay, and a follow-up question, Lindsay. It looks like the price tag on this is about 74 million. Is all of this being funded with clean water SRF money? And if so, is part of this in the form of principal forgiveness? What's the funding mechanism here?
So it is $74 million Clean Water SRF loan, so fully funded by the Clean Water SRF. It is pending loan closing still, so we're waiting to hear more from Tucson, and I'm sure they are also looking for other grant resources as much as they can. And then we are providing, it's about $6 million in loan forgiveness. So.
Great, wonderful, thank you. All right, Sandra. We had a couple questions for you. So similarly for the Cedar Rapids project, what percentage of this project is being funded specifically with the Clean Water SRF emerging contaminants funding?
The final answer on that is yet to be determined. Of course, like Lori mentioned, Iowa's allocation on the Clean Water Emerging Contaminant Fund is only like 1.2 million. And the project's task one itself is about approximately that amount. So for year one, it is quite likely if we do not receive anything else for projects, the entire amount would be funded quite possibly from the emerging contaminants as 100% subsidy.
Great. And another follow-up question for you. I think this was for you. It came in during your presentation. Is part of the project for Cedar Rapids looking at the industrial sources and any kind of pre-treatment for the industrial sources?
That would be something, yeah, the city will probably look into. It's one of the tools in the entire toolbox of PFAS management. But of course, you know, that since that will be a private endeavor, will not be part of the CWSRF funding mechanism. But yes, definitely, that probably will most likely be a part of the overall tools to look into as we move forward into the project.
Great, thank you. I do want to make a general announcement. We've had a couple questions. Will the slides and the recording be posted? Yes, they will. Kim, could you go down to the next slide just to show? This is a lot of information on this slide, but we will put the recording, the slides, and the Q&As onto the EPA website. So we'll just leave that up. Thank you, Kim. Okay. A number of questions came in on how to deal with contaminated sites and remediation of contaminated sites. So is this funding available for remediation of contaminated sites? And let me add on a couple questions to this. Could you do something about the stormwater from the contaminated site or the leachate? Are those activities eligible? So Kelly or Smitty?
So I will try to address this question. The first thing I want to mention, though, is that in this forum, we can't make definitive eligibility calls. We obviously don't have a ton of information about the specifics of each individual project. So I can speak in general terms. I think it's a really good idea afterwards, if you have additional questions, to contact your state SRF program. They can answer specific questions about what is eligible in that state. And then my contact information, I believe, is on the next slide. And then you can always reach out to me and I can either direct you to the appropriate person to speak with or help to answer any additional questions. So when it comes to contaminated sites, generally, the SRF can fund the water quality portion of the cleanup of contaminated sites. That's generally funded under our non-point source eligibility, the implementation of a state non-point source management plan. So the first step would be to determine if the project does help to implement the non-point source plan in your state. And then in terms of eligibility for these specific emerging contaminants funds, that would be dependent on whether there had been an emerging contaminant identified at that particular site.
Great, thanks, Kelly. Could the funds be used for new landfill cells or to collect and treat the stormwater and leachate from the landfills?
So assuming that emerging contaminants had been identified at a particular landfill, leachate collection and treatment, or the management of stormwater from that landfill site would likely be eligible under a couple of different statutory eligibilities. In terms of new landfill cells, I may need to turn that over to Smitty, but we have discussed that before, and I think that it is possibly eligible in some cases.
Right. I guess I could provide maybe just a general example. So if you are dealing with biosolids that is contaminated with PFAS and you need perhaps a dedicated cell needs to be built to dispose of this biosolids, that construction of that cell would be eligible through the emerging contaminant pot of money. So that's just an example of when construction of a particular cell would be eligible. Now, if you are just disposing at a landfill with other ways, municipal ways, that's just more of the operation of disposing of this biosolids. So that's a different thing than, dedicated cell for biosolids.
Great, thanks, Smitty. Are harmful algal blooms or HABs considered an emerging contaminant?
So, Janet, I think I'm going to take, there's been multiple questions on HABs and nutrients, so maybe I'll just take that on at the same time. And if I miss a question, ping me. So, right. So starting with are HABs an emerging contaminant? Yes, and I'm also going to answer another question related to this. We have a definition on one of the links that I presented in the beginning of the presentation, where there's the memo, there's the definition of emerging contaminant, and we also have categories of what the emerging contaminants are, which includes different things. So HABs are considered emerging contaminants, and their removal, if you're dealing with, equipments such as blowers, aeration blowers to control HABs, those are some of the eligible equipment that you can purchase, or a one-time purchase of a chemical that may treat, just flocculent chemicals that may get rid of the algae. Now, going back to a related question about nutrients, right? We all know nutrients being the main cause of HABs. Those are not considered emerging contaminant, and that determination was made looking at the definition of emerging contaminant itself and making sure we have some boundaries around what we say are emerging contaminants, and that came up with the water quality criteria. So anything that has water quality criteria are not considered emerging contaminants. However, if you're dealing with nutrients, there is the regular base SRF pot of money that you can use, right? So we have options. You just can't use the emerging contaminant pot of money. Did I miss any other questions?
No, I think that was good. Right. Thanks for lumping those all together. I was going to go down those. So very good. Okay. Are utilities the only industries eligible for demonstration projects?
No, I think as long as no, utilities are not the only ones eligible for demonstration projects. A project, as long as it's eligible under one of our 12 statutory eligibilities, regardless of whether it's a demonstration project or not, it needs to be a capital project, then it would be eligible. And of course, who is eligible to receive the funding would depend on the particular project type. So for example, the construction of publicly owned treatment works, only municipal utilities would be eligible. In that case, However, if you're talking about stormwater management, there is a much larger suite of eligible assistance recipients there.
Great, thank you. So are pre-treatment activities eligible for this funding? And also such as monitoring out in the collection system to identify sources such as PFAS from your users and those industrial sources connected to the system.
Smitty, I don't know. Well, I think there's kind of two parts that we want to answer here. So Smitty, do you want to answer the part about the monitoring up into the system, and then I'll talk about more capital pre-treatment projects? Sure.
So monitoring for source identification is not eligible for under this fund. But I want to add more caveat to it. So if you're looking at, and this is connected to some type of pre-treatment system, right? If you're doing trunk line analysis, perhaps to identify where you're getting the inputs of, just an example, PFAS, and you can place a capital project to treat that before it gets to POTW. That's a different question. But monitoring for source identification will not be eligible under this particular fund.
Okay, and then when we're talking about capital pre-treatment projects, for the most part, pre-treatment is not eligible for the Clean Water SRF. That is because the way that our eligibilities are set up in the statute is that we can fund the construction of publicly owned wastewater treatment facilities, and generally for pre-treatment, those would be privately owned. There may be some limited circumstances where some pre-treatment activities could be eligible, and I'm happy to discuss those in a different forum, but it is very nuanced and very specific. So if you have additional questions about that, you can feel free to reach out to me, and I'm happy to set up a time to have a further conversation about it.
And same thing with the trunk line monitoring. If there is more questions regarding what that really means, we can have a separate, more thorough conversation depending on what the project is.
Great, thanks, Kelly and Smitty. Next question, can a state use funding from the CWSRF Emerging Contaminants CAP grant to purchase lab equipment to identify and monitor PFAS or other emerging contaminants?
So if, Kelly, do you want to take that? Or?
It doesn't matter. You can go ahead.
If the utility has the ability to do the analysis themselves and they're purchasing the equipment, yes, the equipment itself, the purchase of the equipment itself would be eligible. What is not would be the sample analysis moving on, or the operation and maintenance.
All right, thank you. Question for Lori. What caused the study of the sweetener study in Oklahoma?
So the initial study was to identify any emerging contaminants. So I believe in one of my slides it said there was 110 actually tested for, and 40 of those were identified as present, and they did seasonal studies as well. So the sweetener one, it just happened to pop up in all 4 seasons. So that was just something of particular note in the study. And I think said the pesticides. So that's just something to look further into. But that was one of the listed contaminants that they did in the initial study to help inform this reuse project.
Thanks, Lori. Kelly, are any entities eligible for clean water SRF funds outside of government utilities? For instance, are 501c3s eligible for clean water SRF funding?
Yes, for some of our statutory eligibilities, others besides municipal entities would be eligible. And so it is best to talk with the state SRF program because different states have different regulations and policies in place about who they are able to provide assistance to. But from a national perspective, there are many eligibilities or many project types that where entities other than municipal entities are eligible, and it's open to any borrower.
Great. Here's another question, Kelly. Would these funds be able to cover cost for biosolids, master plans, and technology pilots for utilities facing PFAS issues?
I think to the extent the technology pilot was installing a particular technology at a wastewater treatment facility, something like that would be eligible. The biosolids master plan, I think it would probably depend upon some of the specifics of that plan and whether it was identifying particular capital projects that needed to be put in place. So again, without a lot of additional information, it's difficult to make a determination there.
Right. I'm sorry. And there's a follow-up too. So it would go to a project. They're looking for the design and construction of PFAS treatment of the biosolids.
Yeah, so likely something like that would be eligible.
Right. Great.
At a public facility. Yeah.
Great. Lori, back to you for the Lake Thunderbird project. Where will the proposed treated wetland be located in terms of the watershed?
So that's also part of the study, is to inform the location of the wetland. So that's unknown at this time.
Okay. If funding is used for monitoring and the monitoring shows that there is a concern, but the capital project is not feasible, what happens with the funding when a capital project does not come to fruition as a result of the monitoring?
That's okay. As long as the monitoring is done where it's, integral to the planning and design of a capital project, the option that is selected may be either something that is not eligible for clean water SRF assistance, or it just may be that the utility is not able to move forward with the project at that time, and that's okay. The funding for that monitoring was eligible, and that would not change if the utility chose not to move forward with the capital project.
Great, thanks, Kelly. Can you combine funding from both the clean water SRF and drinking water SRF for different parts of a project? So as example, there's a removal of PFAS using CWSRF for removal of PFAS at the water treatment plant, but then the waste stream from the water treatment plant goes on to the wastewater plant. So for the efforts needed at the wastewater plant, could you use CWSRF for disposal of the wastewater plant, of the drinking water waste streams? Should I repeat that, or did you get that, Kelly?
I think I got it. So
okay, thank you.
So you can certainly combine clean water and drinking water assistance, but the project that's receiving the drinking water SRF assistance would would have to be eligible for those funds. And then the portion that is receiving clean water SRF assistance would have to be eligible for those funds. It is possible that there could be a project at a wastewater treatment facility that receives, I guess I'll call it effluent from a drinking water treatment plant that perhaps has concentrated levels of PFAS due to the treatment that is being done at the drinking water facility. And so something like that would likely be eligible. You just have to be careful about where the project's being done and who is the recipient of those funds. But I think, talking through those logistics with the state, you'd probably be able to work something out where something like that would likely be eligible.
Great, thanks. Here's a comment, a follow-up to something, Smitty, your answer on source identification and projects. So just some more clarification on that. To be eligible, does a specific future capital project need to be identified, or could you identify several capital projects and then select one capital project based on the result of your monitoring information?
Okay, so I'm going to kind of break this question in two, right? And I am going to address the source identification part of it first. So monitoring for source identification, like I said, would not be eligible, right? But if you're looking at future, and I think this, the question is pointing towards future capital project upstream. And I just want to make sure that, that kind of makes me think this is more of a source identification monitoring, which is not part of this. Now, to answer the second part of this question, if you're looking at capital projects to be identified, does it have to be one or multiple? It could be multiple because you're allowed during your planning, your assessment, your design, you're doing alternative analysis. So you may be choosing multiple projects, multiple capital projects, and you may come to one at a future time, right? So that is fine. But I just wanted to make sure we're clear about source identification and upstream treatment. The source identification for monitoring is not, but some pre-treatment of emerging contaminant may be, like Kelly had mentioned earlier.
Great, thanks, Smitty. Well, I think that is it for now. Again, all of this information will be posted as shown in this slide. Kelly, next slide. Thanks, Kim. Kelly or Smitty, any closing remarks?
I just wanted to mention that if you go to the slide before this, there is an upcoming drinking water SRF emerging contaminant webinar on January 31st. So people are interested on that information, please log in and register at the link provided here on the slide.
And I think we'll be able to email out the link to the presentation and the recording to everyone who registered, so you'll be able to find it easily in the next few days. Thanks, everybody.
Great. Yes, thank you, everybody.